Okay, section 3.3, we were finishing up, and we had taken a look at our double angle formulas, and we mentioned that there was a typo on this screen. So if you're looking back at this later, remember that those two on the bottom are actually alternate forms for the cosine of 2 theta identity. And then we had taken a look at some examples, and then we'd looked at power reducing formulas and talked about how to use these. And then the last formulas we were on were the half angle formulas. And the half angle formulas are here. Just a reminder, what this is sort of noting for you in the last one is that notice this has the half angle right here for the tangent. And then over here, these angles are double what they were when the half angle was created. And the example we had done looked like this, tangent of 112.5. And so when we had our 112.5, that's half of 225. So the 225s went in there into the cosine, into the sine. We simplified until we got to a point where we have no radicals and denominators, no double fractions going on, things like that. And it's a cleaned up version of it. Okay, that was in a nutshell. Is everybody okay to continue? Okay, let's give it a try. We have another one here given, but it's given in a much different way. So this one over here had an angle measure, right? We had 112.5 degrees. It seemed rather straightforward on how I would use my formulas to do that, right? It does look very straightforward. This one doesn't look quite as straightforward because I don't have the angle measure theta, right? In this case, it's alpha, but I don't have it. Instead, I have a triangle given to me. Okay, so the formulas that we have on the previous 2 slides ago for sine here still apply. So the sine of alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 2. So I'm going to write that in first. So we'll talk about which one of the plus or minuses we use, because we do have one that we will use on this one, not have a plus or minus when we're done. So this looks like this, and actually this would be alpha, since we're working with alpha on this one. If you mess up the angles and call something alpha and it's theta inside of your like quizzes or whatever, this is not a persnickety kind of thing. However, my math lab will not like you, and it will count you wrong if you mess up on something like that. Just be aware. Okay, so anyway, as we're taking a look at this particular triangle, what I'd like for you to notice is that the 24 and the 7 are both positive, correct? Okay, so the only way that this triangle is going to have a negative in front of the sine theta part right here is if one of the 24s or the 7s had been negative. So this will not have a plus or a minus. It will just be the positive value because the lengths of the two sides, right? We don't have a hypotenuse given. We'll find it in a second, but the lengths of the two sides are positive values. Another way we could say this is that this means that we're automatically in quadrant 1. I know the triangle isn't drawn quite like that, but I have to be in quadrant 1. It's the only quadrant where I have x values and y values that are both positive. So if you want to redraw this in sort of the correct quadrant in sort of terms of your perspective, you're certainly welcome to do that. If I have a 7 and I have a 45, 24, and they're both positive, they have to be drawn in this quadrant. Okay, so if you want to redraw it, feel free to redraw it. If you don't, that's fine too. The point simply is that this is going to be the positive value of the square root, not the negative one. Okay, so if 24 or 7 had been negative, then we would have had to decide, okay, where are we? Do I have a positive or do I have a negative, and how do I make that decision? All right, so using this information then, if we take a look, we can use this triangle because this triangle has alpha in it, right? It doesn't have alpha over 2. So in this triangle, I know the 24 and I know the 7, and I can find the third side. I think this is one we did on Friday or on Wednesday before, but in case it's not, or it's kind of been 5 days, we're going to run through this again and remind you how we find that. So if this is the unknown side, then we have the Pythagorean theorem. So this is 7 squared plus 24 squared equals c squared. If I square these two and add them together, they become 625. And when I take a square root, what do I get? I get 25. So 25 is the missing length. It's the hypotenuse. Okay. And as a reminder for this as well, what you might notice or what you might remember is that this has a name. When these 3 are all whole numbers, they're called a Pythagorean triple. So they have a special name for them, and it doesn't always happen, but there are a few that have shown up in the work that we've done. It's enough that I think that we should mention it. So we do have this as 25. I'm going to move this down here. Okay, that didn't work quite right, but that's okay. We'll fix that. There we go. So over here in my formula, I'm going to have a square root. I'm going to have 1 minus. And in this triangle, my alpha is listed. What is the cosine of alpha in this triangle? So it should be adjacent over hypotenuse, right? So it's 24 over 25. Thank you. So this is 24 over 25 right here, all divided by 2. Okay, everybody okay with that? All right, so at some point here, I've got to consolidate the fact that I've got a whole number 1 and I've got a fraction piece 24 over 25. There's a couple ways to do this. You can get a common denominator just by hand. That's fine. If your calculator deals with fractions and you want to do it from your calculator, that's fine. Believe it or not, I'm not here to teach you how to do fractions again. This is something that you learned before, whether it sort of stuck or didn't. It is sort of irrelevant at this point. Figure it out which way you want to do it, but we're going to figure out what to do with the 1 minus 24 over 25. I'm going to do it by hand, because it's not so bad. This is 25 over 25 minus 24 over 25. And it's all divided by 2, which we'll consolidate in a little bit. So I end up having 1 over 25 all over 2. Okay? You can think about the fact that you're halving something. That's what dividing by 2 is. If I half 1 over 25, I'm going to get 1 over 50. If you want sort of more of a, give me the steps on how to think about that instead of how to think about it conceptually, this is multiplying by the reciprocal. You can do that as well. So it would look like this, 1 over 25 times 1/2, right? If we divide by 2, it's multiplying by 1/2. And I end up getting 1. Actually, I'm going to write, I'll do all at once first. 1 over 50. We'll do it that way. There's several ways that we could simplify our 1 over 50. If you didn't want to multiply it by 50, like write it as 50 before, you can do that. You could leave it as 25 times 2 because it's in factored form. Eventually, we're going to want it in factored form because we're going to want to simplify this. So if you want to leave it like that, that's fine. So I'll leave mine with the 50, and then we'll factor it in a moment. So this is the square root of 1 on the top. That's fine. Square root of 50 on bottom. Well, what's the square root of 1? 1. What's the square root of 50? Well, it breaks down, right? It's 25 and 2. Well, the square root of 25 is really nice. It's 5. And the square root of 2 stays the square root of 2. Okay, all good so far? Okay. I don't want the square root of 2 in the denominator. The 5 is fine. Everybody cool with that? There's nothing wrong with 5 being in that denominator. So I'm not going to touch the 5. He's outside the radical. He's good to go. But the square root of 2 is not. So I'm going to multiply the top and the bottom by square root of 2. And this will leave me with a square root of 2 on top. And then on bottom, I'm going to have the 5 that was there. And then what's square root of 2 times square root of 2? 2. If you want to do that all in one step, that's fine. If you want to do 2 steps, that's fine as well. This is the square root of 2 over 10. And we mentioned last time how we can go about checking that. So let's just check this real quick. Can we? Oh, we can't because we don't have an angle given to us. I take it back. So square root of 2 over 10 right here is where we would stop. We don't have when we were doing this one, if you'll remember, we talked about the fact that we could check the decimal approximation with the calculator by putting in tangent 112.5 degrees and pressing enter. And we put in the square root of 2 minus 1 and press enter and see that the decimals match. We can't do that on this one because we don't have the angle given to us. Okay? All right, any questions? This is a more involved problem than the last one, without a doubt. Any questions on that? Okay. So a little bit more in this section, and they're all the same kinds of problems that we have seen in the other sections. What remains to look at is these ones that say verify each identity. Now, we talked about how we go about verifying identities when we were working with these in the previous sections. The things that we talked about are the fact that you might want to use some identity to change something. You might want to reduce a power, or you might want to take the more complicated side and use it to and simplify it. We talked about changing everything into sines and cosines when there's nothing else that we know what to do. Does that all sound familiar? We've been doing that for a couple of weeks now, where we've been thinking about those processes. So your choice on working from the left or the right, I'm going to choose that we're going to work on the right-hand side, because there's some tricks to this that I'd like to show you, just so that you have them in your tool belt when you're looking at things. So if you wanted to start on the left and show that it becomes what's on the right, you could do that. It would not hurt anything, okay? But let me take a look with you so you can see, not exactly a trick, but a strategy that we haven't encountered before that works really nicely on the right-hand side. So take a look on the right-hand side. Do you notice that everything on the top has a secant in it? Yeah, secant squared, and we got secant to the fourth, okay? So what we're going to do is we're going to factor a secant squared out. Okay, so we're going to pull out what they have in common. They have a secant squared in common. I'm going to pull it out. That's going to give me a 1 in the first one, and then it's going to leave 2 of the secants, or secant squared, in the second one. That's the numerator factored. Okay, it's the same kind of factoring you would have done in an algebra class. We're just doing it with trig functions. The denominator actually also factors, but there's nothing in common to all 3 pieces like there was the 2 pieces in the numerator. So we're going to draw these out like this. I'd like for you to take a look that we have secant squared at the back. Secant to the fourth at the back, which means we're going to have a secant squared and a secant squared. That's the only way we are going to get secant to the fourth. Okay, does that make sense? Okay, it's like when you have x squared and you break it apart into x and x. It's like that. Notice it is a negative though, right? Do you see this negative here? Okay, the only way I'm going to get a negative is if one of them's positive and one of them's negative. So this is a process of elimination thing. If you remember from factoring, your teacher might have told you this is something called factoring by trial and error, right? Like it's a strategy. It's the only strategy that I learned. There's lots of other strategies that are being taught now, but that's the one that I am not necessarily most familiar with, but I've done the longest. Let's go with that. The number at the beginning is a 2. There's only 2 ways that I can get a 2. I can do a 1 and a 2, or a 2 and a 1. And I don't necessarily know which one I want, so I'm just going to pick one, and then we're going to see if it works. So I'm going to put a 2 and a 1 in here, and I want to show you what I mean by see if it worked. So to see if it worked means that we're going to try the middle terms, like the inner terms and the outer terms, and we're going to see if we get the inside, or that middle term right here. So if I do the outer terms, I have 2 and I have negative secant squared. This would be negative 2 secant squared. Everybody good with that? And if I multiply my inner terms, I'm going to have a positive 1, and I'll actually write 1, but you don't have to, secant squared. What is going to happen if I add those together? I'm going to get a negative secant squared. Is that what I want? It's not. So we have 2 choices. One choice is that we can recognize that the only point when we really actually made a decision and did something that we had a choice in, like that made it distinctly different, was when we put the 2 and the 1 in, right? So we can just switch the 2 and the 1. And if we do, that will work just fine. The other thing that we can switch in general is if we have a sign off in the middle, we can just switch the signs. So where you have a positive, you can make it a negative, and where you have a negative, you can make it a positive. So either of those options are good to go. Okay, so I'm going to erase this yellow parts that I've been writing, and I'm going to just change my signs. You can choose to switch the other pieces if you want. That will be fine. So this one's going to be which way did I have it? Negative there. So this is a positive, and this one's a negative now. Okay. Now, can I give you something else that's a trick? This is really helpful. So this doesn't work in algebra in general because you don't know where you're going, but we know what our goal is, right? We know that at the end it's supposed to look like that thing over there on the left. And we know that if we factored, the whole purpose in factoring was that something should have canceled out. Correct? So when I put this in like this, it's not particularly helpful. And the reason if this factored it would not be particularly helpful is that there's absolutely nothing on top that matches perfectly with something on bottom. Do you see that? If this factoring were right, we would not be able to continue the problem. Right? So when we're making the decision about what we're going to put where, hang on. If we take a look at the goal on what's on top of what we'd want something to cancel with on the bottom, our natural inclination here should be to say, I'll bet there's a plus here, and I'll bet there's a minus here. Because if there is, then these are going to cancel, and that's helpful to me. So if one piece, top or bottom, factors easily or more easily to you, factor that one first, and then use that as a guide to see what's going to happen on the other part. It can help you in making your decisions on what the factoring should be. Now, should you still check the inside and outside terms? Well, of course you should. But sometimes you have more flexibility, right? If this number in the front had not been a 2 and it had been a 6, I have more choices. I can use 1 and 6, or I can use 2 and 3. If the number were 12, I have lots more choices. I can use 1 and 12, 2 and 6, or 3 and 4, right? Do you remember doing that when you did factoring in an algebra class? And you just had to keep trying other things over and over and over again, and you're just like, good grief, can't I just land on the right one the first time? Y'all know what I'm talking about, right? Like, it's annoying, right? You're this trial and error, and there's no sort of guiding idea of, well, which one should I try first? Because that'd be nice to know. Well, this tells you what you should try first, because you know the goal. The goal is to cancel something out. So these do, in fact, cancel out. So now we actually have secant square root of x over 2 minus the secant square root of x. Now, that's not the thing on the left, but it's definitely cleaner than we started with. Agreed? We've made good progress, and this is good. So if you get to this point and you were absolutely stuck, you've done about half the work. So that would look like about half the credit. Make sense? Okay. So what should we do at this point? Well, if you take a look back at your double angle formulas, we don't have a double angle formula for secant. They were only for sine, cosine, and tangent. That's all that they were given to us in. So if we're trying to make use of something in terms of double angles, we probably want to make use of something in terms of sine, cosine, or tangent. And which one is helpful when we're talking about secants? Cosine. Secant and cosine are reciprocals of one another. Make sense? So what I'm going to do at this point is I'm going to change everything that I'm working with on the left-hand side into terms of cosines. So this will be 1 over cosine squared of x, and it'll be 2 minus 1 over cosine squared of x. So it's going to get messier before it gets cleaned up again. Okay, does this step make sense? It's okay. Cosines and secants are related to one another. That's why we chose it. Now, I showed you a trick last time about denominators, like when there's a little denominator inside of a big double fraction like this, or the complex fraction. The trick I showed you is that it's really nice to just multiply by that little denominator. So our little denominator here is cosine squared, right? Okay, so we're going to multiply by cosine squared on the top and bottom. Okay, remember, whatever you do on top, you have to do on bottom. And as I'm doing this on bottom, there's 2 pieces on the bottom, so I'm sort of going to have to distribute it. And I think it's kind of nice to just write it beside each of them, so I don't have to draw my distribution. And the reason for that, truly, is because these 2 are going to cancel, and I don't want us to accidentally think that it canceled the entire denominator here, and I'm just left with a 2. I'm not. That cosine squared still has to be multiplied by the 2. So these 2 cancel, and these 2 cancel. So on top, I'm really left with the number 1. Okay. On bottom, this is 2 cosine squared of x. And then I have minus 1. Did everybody see where all the pieces went? Okay, so the goal is to use something with a double angle formula, right? So go back to the very first page, the one that I told you I made the mistake on with my formatting, right? Very, very first page. What is this in the denominator? It is cosine of 2 times an angle. It's one of the 3 formulas that we have for cosine. So this piece in the denominator actually, hang on, let me do this. Actually is 1 over cosine of 2 times my angle. But what do you know about the cosine in the denominator of a fraction? It's secant, right? This is secant. It's exactly what I was looking for. It's secant of that double angle. If I can get the cosine in the denominator of the angle I need, which I did, that's going to be the secant of what I wanted, and that's exactly where I was headed over here. That's a long one. It is, right? And we made things really messy in the middle of it to try to clean things up. And that happens sometimes. Okay, we're going to try another one. You ready? Okay. This one's much shorter. You all said, right? Okay, so this one has sine of 2 alpha cosine 2 alpha equals sine of 2 alpha minus 4 sine cubed of alpha cosine of alpha. If we start with the more complicated side, we're on the right-hand side again, right? We're going to do that. I think that makes a good sense. If you wanted to start with the left-hand side, you certainly could. Those are both double angles, right? Sine of 2 alpha and cosine of 2 alpha. You have formulas for those. So if you wanted to start on the left-hand side and make them, multiplied out from there, that'd be okay too. I'm going to work on the right-hand side. So taking a look at the right-hand side, I have sine of 2 alpha here, and there is a formula for sine of 2 alpha. So flip back again to that very front page. What is the sine of 2 alpha? There's only one of them, one formula for that one.
2 sine cosine.
Yep, this is 2 sine of alpha cosine of alpha. Okay, all good? I'm going to leave the second part the same. Negative 4 sine cubed of alpha cosine of alpha. And I'm going to use that same trick that we used on the last one, which is, okay, there's a lot going on. Is there anything that I can factor out?
2 sine alpha cosine.
Yep. So there's a sine and a cosine and a 2 in both pieces, right? So here's the sine, here's the cosine. Here's 3 sines, so I need one of them. Here's a cosine. And then the 2 and the 4 are both even, so they can both have a 4 or 2 pulled out of them. Now, if you do that, that means there's a 1 left here. Sometimes people forget the 1 when you pull things out. There is a 1. It's like you've divided. Minus, well, the 4 when a 2 is pulled out is a 2. And then sine cubed, when we pull out a sine, would be sine squared. Are these alphas? Yeah, they are alphas. Here we go. And then the cosine got pulled out. The part that's in parentheses is a formula. It's what?
It's cosine.
It's cosine. So cosine of the double angle, right? So choose sine theta, cosine theta right now at the beginning. And then this piece right here, in fact, you know what? Let me back up on that. Both of these are formulas you have. Let's do both of them. Isaiah said that this one is cosine of 2 alpha, and he's right. What's the first one? It's sine of 2 alpha. And that's exactly what we have over here. Okay, so I keep saying that you can work from either side, but I haven't actually shown you one where I've done that. All right? So we worked on the right. It ends up being what's equal to it on the left. I'd like for us to do the same thing and work on the left and see what that would have looked like instead. That be all right with you guys? This is not in my notes, so we're about to see how bad this could go. I'm going to give it a try, right? Okay. All right, so I'm going to clean this one up. I'm going to delete this off. And we're going to start with the left-hand side. If you had looked at this and said, okay, I don't know what to do with the right-hand side. There's too much going on. Let's just start with the left-hand side because at least I have formulas for those. I can change those using formulas because there's formulas that I have that say sine 2 alpha, cosine 2 alpha, and that would be a perfectly reasonable thing to say. The sine of 2 alpha, this one right here, is 2 sine alpha, cosine alpha. Cosine 2 alpha, however, has 3 different formulas, and you may or may not pick one you like. I'm just warning you. But we can change cosine of 2 alpha if we would like. Let me flip back to my front too. And so it doesn't look like it would be a good idea to me to use the cosine. You know what? Let me flip over here. I'll do it from here. Oh, there it was. This one doesn't look like a really good one to choose because it doesn't really look like that's what's going on the left. I mean, on the right-hand side. I don't see a cosine to a power of 3 showing up. So having another cosine in it doesn't seem like it would be all that helpful. And I do see another sine showing up. So this one seems like the most natural substitution to make because it looks a little bit like what's going on the right-hand side. Are you with me on that? So this is the substitution in orange on the bottom that I'm going to choose to make. I'm going to change my cosine of 2 alpha into 1 minus 2 sine squared alpha. So this is 1 minus 2 sine squared alpha. And we're going to distribute it. We're going to distribute it and see what happens, okay? So this is going to have this piece now distributed across here. So if I do that, I'm going to have 2 sine alpha cosine alpha, and then I'm going to have minus 2, and then there's going to be sine cubed because there's 3 sines, and then a cosine of alpha. That's a 4. 2 and 2 make 4 there. Okay, now check it out. I mean, like, that's good progress because that's exactly what I want at the end, right? So I'm really close. The question then is, well, how do I get this piece and this piece to match? And if you take a look again back at the formulas, they do match. The part that's on the left, the one that I'm working on the left-hand side only, the part that's on the left-hand side, that formula is the formula for sine of 2 alpha. So I can make my change here. I can write this as sine of 2 alpha, and then minus 4 sine cubed alpha cosine alpha. And in fact, that's exactly what I wanted this to look like. So that might feel a little bit better if you don't like factoring especially. But it's your choice. Either one will work. Okay? All right, let's try another one. A couple more. I'm not really sure starting on the left-hand side of this one and moving to the right is going to be a very good choice. The left-hand side's real clean. Not much I can do with it. So on this one, you're kind of stuck with working on the right-hand side. Yeah? I didn't say you couldn't, technically, but I don't know exactly how you would make it happen to force what's on the left into the right very naturally, right? It'd be tricky. Okay. However, the right-hand side has a mess on it. It's got some tangents on there. And my goal is to get them into terms of cosines. So there is a relationship between tangent and cosine. It involves sine as well. And you also see that there is a tangent squared here, right? And you also see that there's a half angle. So there's lots of things that we could try, and I'm going to suggest that we're going to work with the half angle part. So we haven't done anything with half angles today from this kind of perspective, but here were our half angle formulas. So we have these versions at the bottom, which are tangent squared, or tangent of alpha over 2, right? We've got theta over 2. So we can pick which one we would like to work with. The one that's in my notes is the first one, but it's kind of messy because it's got a radical. And I think we can use any of them just fine. So do you want to use the first one with the radical and make a mess? Or do you want to try one of the others? Isaiah says first one with radical. Jonas is saying no thank you. It is in my notes. That doesn't, I understand. But I think I'm okay with us changing something else. Jonas, which one do you want to use? The easiest one. I feel like the second and the third one are both very similar, don't you think? You want to use the second one? Okay, let's give this one a try and we'll see how it goes. So we're going to make a change in our tangent of alpha over 2, and in both the locations where we have it, we're going to write sine of alpha over 1 plus cosine of alpha. Okay, let's see how it goes. So we have 1 minus, it's sine of theta over 1, was it plus cosine of theta? Yeah, plus cosine of theta. And this is squared. Maybe we did want those square roots. We might change our minds. Plus, because I forgot those were being squared, sine of theta over 1 plus cosine of theta squared. Do you want to go back to the square roots since the squares and square roots will cancel?
No, let's write it out. You
Huh?
said you wanted to try something.
I didn't say I have to try something new. I was just asking you guys to pick something. Jonas really just wanted something easy. That was his goal. And now we've got a mess. True? Okay. Here's the deal. Here's the deal. You're going to try things that aren't going to work. Do you guys understand that, right? And that's okay. And at some point when you're trying something that doesn't work, backtracking is a reasonable thing to do. Are you with me? So if these had not been squared, I think this would have been a really good choice. But the point when I put it in there and I realized, oh, right, I had squares, it becomes less desirable. Are you with me on that? So I am going to suggest that let's go back and let's put in the square root ones here because I'm going to square things. And that's the only reason, because I'm going to square things. So there's a square root, and that's 1 minus cosine of theta over 1 plus cosine of theta. And the reason that this ends up being nice is because the square and the square root cancel. Notice I didn't put, hang on a second. Yeah, I didn't put the plus or minus in front, and the reason I don't need it is because I'm squaring, and when we square positives and negatives, that they become positives. So if you want to put the plus or minus there and see it cancel, that's fine, but we don't need it. So now I have, and it's still kind of messy because I've got the double fraction things going on, but I would have had that regardless. So this is 1 minus, and then I have 1 minus cosine of theta over 1 plus cosine of theta over 1 plus, and I have 1 minus cosine of theta over 1 plus cosine of theta. Do you see some little denominators? Mm-hmm. Right? A denominator inside of the bigger fraction, right? So we've talked about those before. What we're saying then is that these two pieces, and the fact that they match especially, this happens a lot, it would be nice to multiply by them. So I'm going to choose to multiply by 1 plus cosine of theta, and I'm going to do it on the top and on the bottom. And you can see that I have multiple pieces, so I'm going to do it on the left and on the right, just so that it doesn't cancel out in a way that I forget that I had it there. So on the right-hand side, these cancel. Whoops, that was supposed to be a line. This way. These cancel. That's not thick enough to see. Let's try it thicker. These cancel. And these cancel. Right? Okay, very good. And then I'm going to have to multiply. And then when they cancel to what's on the numerator. And then I have this piece at the beginning times 1. So it just multiplies to it being itself. So I have 1 plus cosine of theta. That's the multiplying by 1. And then I have minus, and I have that numerator, 1 minus cosine of theta. And then in the denominator, I have that 1 plus cosine of theta times 1 again. And then I have the next numerator. I don't really need parentheses around it because I don't have a negative to distribute through. It looks like that. Okie dokie, what happens on top? Well, the ones cancel, right? So when I distribute this negative through, my ones are going to cancel this one, and this one's going to cancel. The cosines don't, because this negative and this negative are going to make this positive. So I'm going to get 2 of them on top, right? Okay, so I have 2 cosine theta on top. What do I have on bottom? I'll have a 2. And 2 cosine thetas.
Did we not write the
I wrote wrong down. I was like, something's wrong because something should cancel. It should have canceled. You probably had it right in yours. This is written wrong. This one should have said negative. There's a negative right there from that one. I did not get it written down right. My apologies. Let's cut that out. So these two cancel. There we go. Very nice. Much better. I'm left with just a 2 on bottom. And then what happens to my 2's?
They cancel.
They cancel. And I'm left with cosine of theta, which was the goal to end with, right?
You only want to get through stuff.
Okay. There is one more, number 10 today. Ready? One more in this one. So again, working left to right or right to left, we have a choice. I kind of like working on the left-hand side. I see some double angle formulas, or I'm sorry, half angle formulas, excuse me. And there's more of a mess on the left. So I'm going to start with working on the left. And we're going to pick a different double angle formula than we did from, or half angle formula than we did before. The one that Jonas had wanted to do is the one that I'm going to pick. Because I don't have any squaring things going on. So it's not helpful to pick the square root ones. So if I take my tangent of my half angle formula, here, let me come back over here and we'll see it. This one, we're going to use that one that's in the middle, that sine of alpha over 1 plus cosine of alpha. That's the one we're going to use. Okay, sine of alpha over 1 plus cosine of alpha. So this will be sine of alpha over 1 plus the cosine of alpha. Whoops. And then, how is cotangent related to tangent? It's the reciprocal. So I'm going to stick with using the same formula that I just used and just flip it because that seems reasonable because I just used it and I'm working with the reciprocal function. So this is going to be 1 plus cotangent over, don't mean cotangent, I'm sorry, cosine of alpha over sine of alpha. It's not the only way to do it. In fact, I don't think I did that in my notes. In fact, I know I didn't because I'm looking at it now. But it seems quite reasonable to stick with the same formula, so we're going to go with it. I do need to get this all merged into one single formula, though, right? I need it to be all together. So I'm going to need a common denominator. So common denominators, the way that they work is that their two pieces are completely unrelated. We're going to have to multiply them by each other. So the first one will get multiplied by sine of alpha. The second one will get multiplied by 1 plus cosine of alpha. Okay, everybody good so far? The denominators match, so they're going to have a sine of alpha in them and a 1 plus cosine of alpha in them. And I am going to leave them factored because eventually I'm hoping some things cancel out. I don't want that all to stay in the denominator distributed. The first piece now is sine squared of alpha. And I have a minus. And then I do need to distribute this and this out. I need a FOIL. So if I FOIL this, I'm going to have 1 times 1 is 1, plus in the inner term and the outer term, they match. So they're both cosine of alpha, so it's 2 cosine of alpha. And then my last terms are going to be cosine squared. Okay, let's see where we are. We have sine squared of alpha minus 1 plus 2 cosine of alpha plus cosine, sorry, I should have had a subtraction there and here. Cosine squared of alpha. I wish it said sine squared plus cosine squared. That'd be better. I'd have it equal to 1. I have it sine squared minus cosine squared. But there is a sine squared minus cosine squared formula that might end up being helpful. It might not as well. Let's pause, take a look at what we have. Let's double angle backwards. So that's not what I want. those to match first. Okay. I don't like where this has landed us.
Let me guess, we did something wrong.
We didn't do anything wrong. It's just that going from here doesn't help us very well. It's harder to see what to do next. So let's go back and do this. Let's cut that. Your poor eraser. Oh, did I just have? Should have been with what's in my notes. That's probably a good plan for that one. That's what I had for the first piece, which is fine. Let's use a different formula for tangent for the other piece. The problem is tangent has 3 formulas, correct? Are you guys with me on this? When you have options, you're always going to pick the option that's going to work very friendly. The other option that doesn't have a radical in the tangent formula is the third one here. So I'm going to go back and I'm going to use that one. 1 minus cosine of alpha over sine of alpha. And then it's cotangent, so I'm still going to flip it. So I'm going to have sine over 1 minus cosine. All right. The denominators don't match, but they are a little friendlier with how they work together. So we still have to get a common denominator. Give me just one more minute. We'll be finished up. The denominator is now 1 plus cosine and 1 minus cosine. And if you multiply that out, you get 1 minus cosine squared. That's actually a formula I've asked you to memorize. The numerator is sine alpha minus sine alpha cosine alpha. And then the second one is negative sine alpha and minus sine alpha cosine alpha. This denominator has another name. Its name is sine squared, because sine squared plus cosine squared equals 1. These add to 0. This is negative 2 sine of alpha cosine of alpha. And then do you see the pieces that cancel? Yeah. The sines cancel here and one of them here. So this leaves me with negative 2 cosine of alpha over the sine of alpha, which is a negative 2, and then cosine over sine is cotangent. There we go. And there we are where we wanted to be. All right.